In this video, we're going to talk about levels of measurement. So this is a different way of classifying data. Previously, we've talked about qualitative and quantitative classification of data. This is another way of classifying data that you might see in case studies. It uses 4 different levels of measurement, and they kind of each build on each other to the next level. So let's go ahead and go through each of them. We'll define them, give examples, and kind of discuss how we tell the difference. So nominal scale data, this is data that is categorical, but has no natural order. Now, let me give you an example of what I mean by data that doesn't have a natural order. Like, let's say I ask people their favorite foods. Let's actually say favorite food, singular. So I have this giant list of food, but putting it in order doesn't actually make sense, okay? Like putting pizza ahead of sushi, right? If somebody says pizza and the next person says sushi, putting one ahead of the other doesn't mean anything. I mean, I could do it alphabetically, but that the order is being imposed. I'm imposing that order. The food itself doesn't have a natural order that makes sense. So I can impose an order, but it doesn't really make sense for the data by itself. Now, important couple things to mention. A nominal scale cannot be used in calculations because it's qualitative. And since we're talking about data that's categorical or qualitative, because qualitative data is also categorical, we can't do calculations. It has no numbers. That makes sense. All right, so ordinal scale. Well, as the word kind of implies, ordinal. This is nominal data that can be put into order. So the ordinal data is also categorical. But it does have a natural order. Wow, that is not how you spell natural. So it does have a natural order. For example, the top 5 national parks in the United States. Here, I'll abbreviate it, the US. That has order. When you have a first, second, third, fourth, and fifth, that actually has an order and meaning. So this naturally has an order, just the way it's classified, but it's also categorical. So when you say Zion National Park is my favorite national park, and maybe it's the top national park for this list, that makes sense in terms of comparing it to other categorical data. So it has order. But like nominal data, you can't do calculations still. Because again, it's non-numerical. Well, that's going to change. So interval scale data is data that does have order, but it's numerical now, which all numerical data has a natural order to it. So that makes sense. So it is data that has order and taking the difference between data values has meaning. Or maybe I should say is possible. So we're finally looking at numerical data. Now, there is one important thing to say about this data. We say that interval data has no starting point. And what that really means is that when you say zero, zero doesn't have meaning in the sense that it doesn't actually represent some sort of starting point. So zero doesn't mean nothing. Let me give you an example of data that's numerical, but zero doesn't mean nothing. Temperature. That makes sense. Because when you talk about temperature, you can take the difference between two temperatures, right? You could do 100 degrees. Here, we'll use 100 degrees Fahrenheit minus 60 degrees Fahrenheit, and that equals 40 degrees Fahrenheit. And that fully makes sense. Like to talk about these temperatures and subtracting them. That makes sense. It totally makes sense. But 0 degrees Fahrenheit doesn't mean it's the starting point of the temperature scale. And it doesn't mean that there is an absence of temperature. So 0 degrees doesn't mean nothing. It actually has a meaning, and it isn't a starting point because there are negative temperatures below 0 degrees and they exist. And so, yeah, it's not a starting point. It doesn't mean 0. It does, obviously, we can do calculations because we can take differences. Now, ratio also can have differences. So data that, that's not the word, that can have differences. So it's numerical. But in this case, it does have a starting point. Wow, and that is not how you spell data. Sorry, I just got that. Data that can have differences, and it does have a starting point, which means 0 means nothing. So let's give an example. Test scores. So like when you have like a test score of 62 and 78 and 93, okay, those types of test scores, they are numerical, they have order. And when you say that somebody gets a test score of 0, that means 0 as a test score means that they scored nothing. I'm going to abbreviate the word points. Okay, but there is one other distinction between the interval scale and the ratio scale. So I kind of left a little space because I did want to go back and fill this in. So for interval data, it doesn't make sense to talk about data having some sort of comparison by multiples. Here, multiple, or wow, that's again not how you spell multiple. Multiples, right here, let's say it this way. Comparison by multiplication doesn't make sense. So just to kind of drive that home, when you say 4 times as hot as 20 degrees, that isn't 80 degrees. 80 degrees is not 4 times hotter than 20 degrees. That makes no sense. But with test scores, that does make sense. So with ratio values, that makes sense. In ratios, comparison by multiplication does make sense. That looks like an A. Comparison by multiplication. Makes sense. So when you say that somebody scored 20 points on an exam and another person scored 80 points on an exam, they did score 4 times as many points. That does make sense. That comparison makes sense. But when you're talking about like temperature, that comparison does not make sense because it doesn't mean it's 4 times hotter. That's not what the difference between 20 degrees and 80 degrees is. It's not a measure of the hotness in terms of like how the heat is multiplied. It doesn't work like that. So that's the levels of measurement.